Apologies again. I forgot to click the button that says that you can record the conference, so it's not letting me go back in and edit that and record this. So I'm glad you're here. I'm going to walk you through it. People at home, I'm sorry that I didn't record it the right way, but I'm going to work through the problems that are on this new review that I made and then open it up for other questions. So here is the review again. That's how I get to it at the bottom of the module. And I'm going to start with the problems that I put up on the board. Please turn on your microphone to ask questions if you have any. Good morning, Sabrina. If anybody wants to ask by putting in the text window, you can also do that. So, the first question says to graph using the intercept method, and then it gives me 6x plus 5y equals 30. The intercept method really asks me to plug in 0 for x, solve what I get for y, plug in 0 for y, solve what I get for x. So I'm going to do that off to the side. If I plug in 0 for x, I get 6 times 0 plus 5y equals 30. 6 times 0 is 0. 0 plus 5y is just 5y. So this becomes 5y equals 30. If I divide by 5, that gets me to the answer of y equals 6. As an ordered pair, that means I put in 0 for x. I got back a positive 6 for y. This is my first ordered pair that I get using the intercept method. If I go and do the second ordered pair, I would put in 0 for y, so I get 6x plus 5 times 0 equals 30. 5 times 0 is 0, so this term goes away and just gives me 6x. So it becomes 6x equals 30. If I divide both sides by 6, that's how I get x equals 5. So that gives me the ordered pair that I get back 5 when I put in 0 for y. Now that I have two ordered pairs, I just need to put those two ordered pairs onto the graph and connect them into the line. So 0, 6, 0, 1, 2, 3, 4, 5, and then I need to make a sixth. 5, 0, I go right, 1, 2, 3, 4, 5, then I go up or down 0. If I connect these into a line, it should look something like that. And my line curved a little, apologies. Obviously, you do a straight line when you do it out on the computer. I'm going to do that for the people that can watch on here. Apologies again for the people that I am not able to record this for. So if I go into the app, and I click on the line tool, I select make sure it's highlighted this first version with the 2 arrows on each end. I can put a point in here at 6. I can put a point in here at 5. I can click off of them and it'll draw in the line. So I know that I've shown in the past putting the points in individually. After putting the points in using the line tool to connect the points, it works this way as well. I realize somebody told me I don't need to do those first steps, but I also like using the point tool instead, first putting in the 2 points, and then once they're locked, using the line tool to connect the 2 points. But you absolutely can skip the step of putting in the points and just jump right to the line. This is the line as graphed, what I would submit to Cengage. All right, so back to the big screen. Second question says, graph the equation x equals 1.5. This is a situation where hopefully I remember that x lines are vertical lines that go straight up and down at whatever the value is. If you don't remember that, as long as you can remember that points are x, comma, y, all you have to do is make up 2 points where this is the x. So as long as I do 1.5 comma something, 1.5 comma something, those 2 points will always combine to make the line. If it's the x value, you put it in as the first coordinate that's static. If it's the y value, you put it in as the second coordinate that's static. In this case, I can put whatever I want for y, so I'm just going to put 0 and 1. If I go to graph these points, 1.5, 0 is there. 1.5, 1 is there. I can draw in the line like that. This is the graph of the line, x equals 1.5. To show how to do it on The app is a little trickier. So here, if I, in the app, clear the line that I had previously, and I go to the line tool, and I want to be at 1.5 and 1.5. It's not letting me. It's picking whichever one's closest. It's not letting me draw in something and a half. So I don't want that line. That line is not the one I was told to graph. What I want to do is first put in the points. So here I'm trying to put it in at 1.5, 0. It won't let me. But when I click on the point tool, I can change it and make it so that it's specifically 1.5, 0. I can then take a second point and I can try and put it at 1.51. But again, it goes back to a place I don't want it. So I go in and I change it to 1.5, 1. Now that those 2 points are graphed, I can go into my line tool, select the double-sided line, click on the first point, click on the second point. That did not work. Sorry. Let me clear out that line. Click on the line tool. I apologize. I thought this would let me work. Let me see if I do it. If I put it in as the line tool and I click on these points where it wants me to be, I can open up the line and put the points in that way. I really thought I could do it once the points were set, that I could then go to it, but same way that I can change the points when I'm just clicking them as points, when I have them as 2 for a line, I can change that. Right now it's a solid line, which I want, but I can change it to a dash line or something like that. When I click off this, it'll draw in the line like that. I think for the most part, or even entirely, they make you only graph points that have the decimals, or else they make you identify lines that are already drawn, but don't make you actually draw the ones that are decimals, if I remember correctly. Either way, that's how I'd do it if I had to do it. The third one, you should be looking at the graph that's in front of you, but I redrew it best I could up here. It might be a little harder to see without the grid lines, but basically, the first point starts at 0, -1, 2, 3, 4. So in order to find the slope, I'm going to pick that point that I can see on the graph that's occurring at a cross, meaning where 2 grid lines cross, and I'm going to go down to this other point down here that's occurring where 2 grid lines cross. What I'm going to do is start at the point on the left and say, to go from the point on the left towards the point on the right, how many do I move up or down, and how many do I move over? So starting at this point on the left, to get to this point on the right, I go down 1, I go right 1, 2, 3. Down 1, right 1, 2, 3. So a slope is always rise over run. In this case, down 1, right 3. Based on whether it goes up or down, you make it positive or negative. Up, leave it as a positive value. Down, make it a negative value. Since this time we went down 1, I'm going to make it a -1. Right 3, as you move to the right 3 places, I'm going to make just a +3 underneath. Always move to the right. If you're moving to the left, it makes everything a little more complicated. You got to see things in a different way. If all you ever do is make the rise up or down, that makes it positive or negative, and no matter what you go to the right, you won't have to worry about it. So here I should be getting a slope of -1/3. This is the graph of the second equation. This is the graph of the first equation using these 2 points that I calculated. So those are the first 3 problems. Let me bring up the next set of problems and do those. Before I erase what I've done on the board, are there any questions about what I've done so far? Okay. What can I help you with, Maria? Okay, let me make a couple more like that. Okay. Yeah, I can do it up here on the board. So I'm gonna go full screen. I'm just gonna draw in some lines and then we're gonna figure out how to find the slopes of them. Okay, so I just drew 3 lines in. Our goal is going to be to find the slope of each of these lines. So the first thing you want to do is identify a starting point, somewhere on the left of the graph where you can clearly see where it's intersecting in the x direction and the y direction in a grid line. This first one I did where it has 2 clear intercepts. So if I start here, this point, if I wanted to label it, I went left, 1, 2, 3, up or down, 0. So this is really -3, 0. It crosses at the intercept here, where I went left to right, 0, and up, 1, 2. So this is the point 0, 2. So these are the 2 points that I'm really using to find my slope. I don't need the numerical xy values, I'm just trying to put them up there so you see how I'm getting to where I'm getting to. So starting from the point on the left, in order to get to the point on the right, I move to the right 1, 2, 3, and up 1, 2. So if I see this as rise over run, starting at the point on the left, I go up 1, 2, so my rise is up 2. I then go to the right 1, 2, 3, so my run is 3. Always has to be to the right. Up means positive, so 2/3 is my slope. If I do the same thing with these 2 points, this point was intended to be at -1, +1, 2, 3, 4, 5. This point was intended to be at +2, -1. So in order to get from here, from here to here is what we're doing. The vertical distance that I go, going from a vertical height of 5 to a vertical height of -1. I go 5 to get to 0, then 1 more to get to -1. So this side goes down 6. To get from here at an x value of -1 to here at an x value of +2, this side means that I moved right +3. So that means that as rise over run, I went down 6 and I went right 3. Down 6 is -6, right 3 is +3. So this has a slope of -2. You can also see that if I went to this first point where it intersected, here I went down 2, right 1. This point, down 2, right 1, would have gotten me to that same slope of -2. Same thing here, I could have gone down 2, right 1, and saw that was a point, down 2, right 1, and saw that was a point. So I don't need to identify the same point to get the same slope. It could be that you saw these 2 points and wanted to use those. But the general idea is identify 2 points, starting from the one that's to the left, figure out how many up or down you have to move and how many left or right you have to move to get to the one on the right. If I do it for the last one, I intentionally did this as a horizontal line. A horizontal line doesn't go up or down at all. So if I pick 2 random points, I could say here and here. This first one is 0, 3. The second one is 2, 3. So here as I move between them, I move right 2, and I don't move up or down any. Up or down 0. So as rise over run, I'll call it up 0 over right 2. that equals 0 over 2, which equals 0. Here the slope is 0. If I tried to do that for rise over run for a vertical line, I would get something where I was dividing by 0. Dividing by 0 gives me an error, which makes the slope undefined. Hopefully that addresses what you were asking about, Maria. Again, really the best way to do these is just to try examples, to look at the other examples that are up on the classwork and other ones like that, and just try and work them in Cengage. But you know, the goal here is pick out 2 points, figure out how do I get from the first point to the second point, reading from left to right. All right. I'm going to go ahead and erase what's on the board and focus on the next types of problems. So problem 4 says find the slope. We're given -1, 5, and 3, 4. I'm sorry, might as well go full screen so you guys can see what I'm writing. You're welcome. All right. 5 says graph, and it gives us the point -3, 4, and m equals -2 over 3. And then number 6 says we need to know whether these are parallel, perp, or neither. And we have 2 sets of points, 1, 2, and 4, 3. Then we have -5, -3, and 1, -1. All right, so where we're gonna start is with the slope formula. Hopefully you have the slope formula written in your notes, but basically what the slope formula says, m equals y2 minus y1 over x2 minus x1. So if I want to label these points, I'm going to give the one that they gave me first the label point 1. So this is going to be x1, y1. Point I got second is going to be point 2, x2, y2. Plugging into my slope formula, it says take y2, which is 4, subtract y1, which is 5, over take x2, which is 3, subtract x1, which is a -1. On top, 4 minus 5 gives me -1. On bottom, 3 minus a -1 is really just like 3 plus 1. 3 plus 1 gives me 4. So I get a slope of -1/4. All right. For number 5, it gives me a point and a slope that I need to graph. In order to do this, I'm going to start by making my grid lines. 1, 2, 3, 4. All right. -3, 4 means I start at 0, 0, go to the left, 1, 2, 3, go up, 1, 2, 3, 4. So let's say it's about there. A slope of -2 over 3, I need to read as rise over run. What this really means is down 2, right 3. So from this point, I'm going to go down 2, and then I'm going to go right 3. This would be the graph that I want to draw. On the computer, if I wanted to see what that looked like in the app, then I would go to the app tool. I'm going to clear what was previously there. I'm going to put in the point that I was given. So the point I was given was -3, 4. Once I've put in that point, I'm going to select the point tool again, and this time I'm going to use the slope that tells me down 2, right 1, 2, 3. I then put in that point. I'm going to click onto the line tool now. I want this point and this point to give me that line. For number 6, it asks me whether these lines are parallel, perpendicular, or neither. So the goal here is to use the slope formula that we used above to find the two slopes and then compare them. If the two slopes are the exact same, then they're parallel lines. If the two slopes are negative reciprocals, meaning they're a fraction flipped, one negative, one positive, or in other words, when I multiply the two slopes, I get an answer of exactly -1. That's when I would declare them perpendicular. If it's not either the same or negative reciprocals, that's when I would call them neither. So 1, 2, and 4, 3. Here I'm going to start out by saying this is x1, y1, x2, y2. I'm going to set up 3 minus 2 over 4 minus 1. That gives me 1/3. When I do the same thing for the second set of points, x1, y1, x2, y2, then I get -1 minus -3 over 1 minus -5. Let me just double check that I'm doing the right points here. 1, 2, 4, 3, -5, -3, and 1, -5. Alright. So on top, -1 minus a -3, that gives me -1 plus 3. -1 plus 3 is a +2. On bottom, 1 minus a -5. 1 minus a -5 is really 1 plus 5. That gives me a 6. I can reduce 2 over 6 to 1 over 3. So in the end, I get the same slope. 1/3 equals 1/3. That's why I select parallel. If you're not sure if the fractions are the same, and you're not great at reducing fractions, you can always check if the decimals are the same. If I put in 1 divided by 3, my calculator would tell me 0.333333. If I put in 2 divided by 6, my calculator would tell me 0.333333. So if you do this correctly and get the right final answer, but you're not sure if it's fully reduced, just put it in as a division problem and see if you get the same thing. I'll pause here for a second to see if there's any questions on anything that I just did. So is there anything, questions specific to using the slope formula, graphing from a point in a slope, or the idea of finding parallel and perpendicular? So I see somebody typing. I'm going to wait a second to see what the question is before I erase. And I apologize. I know it's tough to type in real time. It'd be much nicer to be face to face, but definitely you don't need to rush. Ask your question and I will see what I can do. Finding parallel again. Okay. So once you find the two slopes, this whole process, this is all the same thing as what we did in number 4, finding the slope. Once I find the slopes, if they are parallel, two slopes equal. So these have to be exactly mathematically equal. If I put into my calculator 1 divided by 3, this equals 0.333 repeating. If I put into my calculator 2 divided by 6, this equals 0.333 repeating. These are mathematically identical. So if they're the same, That's when we say that they have parallel slopes. Perpendicular. Slope times slope equals -1. If you put in, for instance, 1/3 times -3, that would give you exactly -1. If one of these lines, so if I had this set of points and I got 1/3, and then for the other one, instead of also getting 1/3, I got -3, I would check and say, well, let me see what happens when I take -3 times 1/3. When I got exactly -1, I'd know that this is a situation where they're perpendicular. You also could just see that really 1/3 is the flip of 3/1, one of them positive, one of them negative. That's what makes it into a negative reciprocal. So I think the easier way for students to see it who struggle with this concept is to try multiplying them and see if they get -1. If it's not that they're both equal, it's not that they multiply to -1, you select neither. So a vast majority of lines should be neither, but really, obviously the ones they're going to give you are somewhat cherry picked, so you're going to see it more often than not that they're either parallel or perpendicular, but in real life, most lines aren't parallel or perpendicular. Most of them intersect at just one point, which we'll get into in the next unit when we talk about systems of equations. All right, thank you for the question. Hopefully that's a little more clear, but it's definitely a little bit confusing, the concept. So I'm going to go full screen again and put up the next 3 problems from the review, and then open it up to just general questions after I get done with these 10 problems. All right. So let me erase this. Question 7. Find slope and y-intercept. This was 2x plus 5 equals 1. Another one where we're finding parallel, perp, neither. This time we're given 2 equations. Y equals -x minus 10 and y minus x equals 3. For number 9, we need to find slope and y-intercept. Given 3x minus 2y equals 14. And finally for number 10, write the equation of the line. And here we have a slope, m equals -3/4, and an intercept of 0, 2. Alright. So for the first one, or the 7th one, really find the slope and y-intercept. 2x plus 5 equals y. This might look a little out of place, but really this is in the exact form we wanted it. It does not matter which side of the equation something's written on. I'm used to showing everything. Move all the y's to the left, move the x's and numbers to the right, but really at any point you can just flip which side things of an equation are on. When I say you can just flip, I mean you can trade everything on the right for everything on the left. You can't like flip one thing, but what I can do is rewrite this as instead y equals 2x plus 5. So all I've done is taken everything on the right, move it to the left. Everything on the left, move it to the right. Everything on the right, move it to the left. I'm allowed to switch both sides of everything. Really, I could do this by just subtracting, and then multiplying by -1. That said, I have had students send me Ask Your Teachers confused about why is y on the right-hand side, shouldn't it be on the left? So I get that that's confusing to see it that way, but I can really just rewrite it like this. Now that I have that, I need to see m, or the slope, as in front of the x-coordinate, and b, or the y-intercept, as behind the x-coordinate. That means for this equation, the slope m is what's in front of the x, which is a 2. The y-intercept, or b, is what's behind the x, which is a +5. But they want us to write it as a y-intercept. As a point, it's always going to be 0 for the x-coordinate, and for the y-coordinate, whatever b is. So the answer that I'd put in for this problem, if I was doing it on Cengage, is m equals 2, y-intercept equals 0, 5. For question 8, it asks me, are these two equations parallel, perpendicular, or neither? For this, all I care about is the slope. So for the first equation, since it's already in y equals mx plus b form, I can pull out that slope is just what's in front of the x. So here this has a slope of m equals, it's a negative sign, but I don't have a number associated with it. When I don't know the number that's in front of x, my default is that it's 1. So here this is really a -1. If I go down to the second equation, I don't want to jump to write what's in front of the x. I need to first make sure it's solved into y equals mx plus b form. It's not right now because this is on the wrong side of the equal sign. If I add x to each side, on the left-hand side, I'm just left with y. On the right-hand side, 3 and x are not like terms, so I cannot combine them, but I can write it as x plus 3. Once I have it written as y equals x plus 3, I look in front of the x. There's nothing there, but there's really an understood 1x. That's why the slope m equals 1. I now need to do my tests for parallel, perpendicular, neither. For parallel, are they the same? -1 and 1 are not the same. For perpendicular, are they negative reciprocals? Well, if I think about them as a fraction, this would be -1/1, this would be +1/1. Really, if I flip them, they stay the same, so they're the same as they were. This one's negative, this one's positive. These are perpendicular. Even if you didn't see them as fractions and all you said was, well, let me test the way Mr. Moulton showed me to see whether these are perpendicular or not. If I do this slope, -1, times this slope, 1, -1 times 1, do I get exactly -1? I do. When you get exactly -1, yes, they're perpendicular. So these two lines are perpendicular lines. Let me go off full screen real quick, see if there's any questions on those first two. Alright. I saw somebody typing. So just while Emily's formulating her question, let me just go back over. In general, we want to get things into the form y equals mx plus b, where m is the slope that's in front of the x, b is the intercept after the x. Whenever I just see an x, there's an understood 1 in front of it. X just means 1x. The answer for 8 would be perpendicular, yes. But again, this one doesn't have a quiz associated with it. You're never going to turn these problems in. These are just for your review. So you don't need to get the exact answers to the questions as much as you need to follow the logic and let me know where I'm losing you if you're not sure how to do these problems when they're going to come up on the test. But yes, it is perpendicular because they do multiply to -1. All right. Number 9, find the slope and y-intercept. They give it to me where I don't have the equation in line yet. I'm going to need to do a bunch of steps to get it into y equals form. So here I start off with 3x minus 2y equals 14. I'm going to go ahead and subtract 3x from each side. That leaves me with -2y equals -3x plus 14. Again, make sure that you see why 14 and -3x don't make 11, don't make 11x. I cannot combine something without x's with something that does have x's. It needs to stay negative 3x plus 14. Now that I have the y's on the left, then the x's and numbers on the right, I'm going to divide by what's in front of the y. I'm going to show this in 2 steps. You're welcome to do it in 1 if you like dividing by the negative, but I'm going to worry about the 2 first and then worry about the negative. Negative 2 divided by 2 just gives me negative 1, or in other words, negative y. Negative 3 divided by 2, it can't really simplify, so I'm just going to leave it as negative 3 divided by 2x. Positive 14 divided by 2 gives me positive 7. To get rid of this negative, what I'm really doing is changing every sign. So I'm going to write it as multiplying by negative 1. Really what that means is take what was a negative y, make it a positive y. Take what was a negative 3 halves x, make it a positive 3 halves x. Take what was a positive 7, make it a negative 7. So in order to change this negative y to a positive y, I have to change the sign on each of the other terms. I can now pull out what's in front of the x as the slope. So my slope would be m equals 3 halves. I can pull out what's after the x as my b. So my b would be negative 7. That means as a point, the y-intercept would be the point 0, comma b, or in this case 0, negative 7. So again, I start out with this equation, I rearrange, I divide, change the negative, so that I get in the form y equals 3 halves x minus 7. Once I have it in this form, then I can pull out the slope as in front of the x, I can pull out the b as after the x, and that gives me the y-intercept 0, negative 7. When I go to write the equation of the line with slope negative 3/4 and y-intercept 0, 2, what I really want to pull out is that this means that b equals positive 2. So when I go to create the line, I write a generic y equals, I write in the slope, negative 3/4, then I write the variable x, and after that I write b, which in this case would be positive 2. So all I'm really doing is taking the given slope, writing it in front of the x term, taking the given y-intercept and writing it after the x term. If this had been a negative number, then I'd want to write minus the number instead of plus. If it's a positive number, then it's an understood plus. So let me see if there's any questions on any of that I just did. So again, for find the slope and y-intercept for number 9, I ended up finding a slope of 3 halves, a y-intercept of 0, negative 7. And for write the equation of the line, I ended up with the equation y equals negative 3/4 x plus 2. What ideally would happen now, we've got about a half hour left, a little less in this conference. So ideally you guys would tell me, can we see more problems like number and say any of the numbers I've done, or pick anything on the sample test that I didn't go over that you'd like to see. But basically that's everything that I have prepared that I want to go over. I would love it if you guys have questions that I could answer for you. We go over the answers to the questions one more time, please. Okay, let me bring it up on screen, but I'm going to go ahead and turn off the recording that I'm doing up here. Give me 1 second.